What's up? Welcome back. This is part 2 for day 15 of the Advent of Code with Ruby. And if you haven't seen part 1, you can head over and see how we implemented part 1 in the previous episode. Now in part 2, rather than just looking at a single row, in part 2, we need to look at this massive grid that is between 0 and 4 million. So it's like a 4 million by 4 million grid. We have our sensors and our beacons. And again, a sensor is tied to exactly one beacon that is a certain distance away from the sensor. And there's no beacons that are closer to that sensor. And that beacon is tied to exactly that one sensor. What we get is this sort of like overlapping regions where the coverage, where a sensor would have otherwise detected another beacon that was closer, they're all overlapping except on this 4 million by 4 million grid, except one point. So there's like this giant overlap of all of these different squares, except there's one point where it's not overlapping, and we need to find that exact point. I actually had a really hard time with this part too. And so I looked for some hints, got some ideas. And so one of the ideas is to look at all of the edges for all of your squares. And if you step one outside of that, then you create a boundary around your sensor that is the distance plus 1 from the beacon. And what that does is it creates this like almost like a 1 pixel square around all of the squares. And then what you can do is collect all of those points that are exactly distance plus 1 away from the sensor. And you can look at every single one of those points to make sure that it is not already covered by another sensor. And at the end, you'll end up with just one point. It's worth mentioning that it would take like hours and hours or longer, especially to look at a 4 million by 4 million grid. And even with the approach I'm about to take, it's going to take several gigabytes worth of memory. Let's jump into it. Okay, so we are still collecting up our sensors and beacons, and we're still going to use this distance, but I'm going to comment out part 1 here. And so now what we want to do is find all of the points that are around a sensor that are D plus 1 from the sensor. I'm actually going to use GitHub Copilot here. So I'm going to say gets all the points around a point that are exactly D plus 1 away. And we'll make a method here called get points that takes in the point and some D, and then we'll let GitHub Copilot write this. Okay, I want to do this a little bit differently. We're going to do like from minus D to D. D is the distance from this point to this point, right? So this is 2. And we need to iterate over 2 and then 1 and then 0 and then -1 and then 2 again, right? If we're just looking at the X axis here, we're just trying to figure out what is the X for all of these. We need to go 2, then 1, right, for this one, then 0 for this one, then -1 for this one, and then -2 for this one. So we want to go from -2 to 2. And for each of those points in between, we also want to go out in the other direction. And so here we're going to say something like, this is going to be our dx. And we need to see, okay, so dy is d minus the absolute value. Yeah, so the distance minus the absolute value of the change, that's going to give our dy, because they're always going to be related, right, as you're like drawing out the line. Okay, then what we can do is add into our list of points the going up in that direction, and we're also going to add in the list of points going down in the other direction. This will draw it like this and like this at the same time, and then we'll come back in together at the same time. So hopefully that makes sense. We end up with this method called get points, and that should give us all the points from a given point. So now what we want to do is we want to iterate over all of the sensors and get all of the points that are D plus 1 away from the sensor. So sensors.each do sensor. We need to collect up all the edge points. So we'll say edge points plus equals get points of the sensor D plus 1. And then at the end of this, so edge points is a set. We should have like p edge points dot size. So this is going to be puts like finding edge points and that many edge points. Let's just see if that works against the example. Okay, so finding the edge points, it found 271 edge points. Rather than using plus equals here, because this is going to do like a concatenation, which will require that we keep track of a giant list of points. And also when we do this concatenation, it's going to have to move them over, allocate memory, and do all this other crazy stuff. So I think it might be faster. Maybe I'm wrong. If we pass in the edge points here as an argument, so we say EP, and then we say EP shovel, and then we don't return anything. It's just like we're passing in the set that's going to be modified. We should get the same answer. And I don't know if it's actually faster, but okay. Now we need to iterate over each of those points and make sure that they're not near a beacon. So now we have to say edge points dot each edge point. And now we want to go from each sensor, and we're going to again have an exclusionary set. So we'll say if the distance between the edge point and the sensor is less than or equal to D, that means it's like inside the range of another sensor, right? So we're going to have these overlapping regions where one square is going to be overlapped by another square. And where that overlap happens, the points that are just one outside of the edge of the other square are going to be inside of the region for the other square. So at the end here, we should have edge points should be one more than excluded. So let's just P edge points.size minus excluded.size and see what we get. Sensors.each. Okay, 105. So that's too much. We need to exclude any points that are outside of our range. We haven't done that exclusion yet. So let's actually do that. We'll do that here. We'll say like next if x plus dx is greater than 0, or x plus dx is or if it's less than 0, or if it's greater than 4 million, then we're going to skip it. And then we also want to say next if y plus dy is out of range. And then down here we want to skip if y minus dy. I think, let's see if that gives us better numbers. 46. Okay, so now where are we having overlap? Let's just print all the edge points and see what's going on here. Okay, these all seem reasonable. All right, so then, okay, so I jumped the gun. For the actual input, they have to be between 0 and 4 million, but for the example use case, they have to be at most 20. So let's do like this like max XY thing. In the example use case is 20, and then in the actual use case, it's 4 million. Oops, is that the right number? 4 million. Okay, so then instead of using this here, we want to do max XY. Max XY. Max XY, and then we'll run this again. Nope. So it's not in scope because we're using this method. I'm just going to make it a constant called max. All right, and then we'll change these all to... Oh, look at that. Okay, we got 1. 1 is what we want. So now when we look at edge points minus the excluded, we should get exactly 1 point. And we do. And the set is 1411. And that is the answer here, 1411. So we're going to now print out. So this is going to give us an x and y. And then we want the answer is going to be, let's see, multiplying the x coordinate by this number. So puts the x coordinate times this number plus the y coordinate. Okay, so we'll run that again. Part 1 in the test use case is that. That's good. So let's run it against our input. And again, we have to wait for a minute. All right, so it found 47 million edge points. That's a lot of edge points. So now it's iterating over every single one of those edge points around all of those different squares and checking to see if it's in the bounds of the sensors. And if it is, then it's being excluded. If it's not being excluded, blah, blah, blah. And then we're going to get hopefully we get some point and an answer here at the end. All right, it looks like we got some points. So this should be the easy part, which is taking x and multiplying it with 4 million and then adding this. We get back this humongous number, 12 trillion something. It's the national debt. I don't know. That's the puzzle answer for part 2. Let's take a look at what's going on. This was like a very mathy problem. And yeah, so there's a couple of things that I've tried to play around with and try to make it faster. So one is removing all these function calls. So instead of having a method get points, I just move this stuff inside of where it's calling get points and then iterate over each of those points. And then the same thing with distance, like trying to pull that out of a method in here. I don't know if that actually sped anything up too much. There's probably a bunch of other little tweaks that you can do to make it faster. But again, this one was super tough for me, but hopefully I explained the process and you can understand the code. So that is day 15 of the advent of code. Thank you so much for watching. See you next time.